describe the end behaviors of each graph, right? So we're going to talk about what's happening on the left and the right. The possible number of turning points and the possible number of zeros. We're going to put all that stuff together. Possible number, right? So we'll list it. Like it might have 3, 2, 1, 0, 0, stuff like that. Use these characteristics to sketch 2 possible graphs of the function, right? Because we don't know exactly what it looks like later. Yet later on, we're going to learn to factor it. So we're going to learn how to factor something bigger, like with powers of 5. Then we're going to break down the factors, and we'll be able to sketch it better. But they're saying possible. Okay, so possible ones. Use these characteristics. Yeah, so 2 possible graphs of the functions. All right. So first of all, we look at the first thing we always do is we're going to look to see the leading coefficient and the highest degree. Okay, so I usually just go leading coefficient. So I'll kind of do LC is the leading coefficient. It doesn't mean anything. I'm lazy to write leading coefficient over and over again, so we'll just do LC. Some teachers just go coef, right? They just do that part, but I don't know. I'll put LC. Okay? So when we're doing our notes, sometimes I put LC leading coefficient. So here, I want to know in my brain. You don't have to write this, but I'm just going to do my little bubble of knowledge thing, right? So it's kind of like, what do I want to think about? As soon as I get a question like this, my first instinct is to go with my brain, okay, what do I need to know? The leading coefficient is negative. So negative, right? I don't need to know the number. I just need to know it's negative, right? And I also want to know that the degree, right? The degree of it, look here, is 5. So I know that the leading coefficient is negative. Okay, so it's negative. And I know that the degree is 5. Those are my 2 most important things. It's negative and it's 5. So then in my brain, I go, okay, so that will have the same characteristics as a line, right? So odd is line, and it's facing down. So I do this in my brain on the side. I go, okay, like this. I'm picturing a negative line, a negative sloped line. Okay, now I can talk about other things, and I'll draw little sketches on the side. That's why I said I kind of visualize, and then I'll talk about it. So end behaviors then. So my end behavior would be, describe the end behavior. So end behavior. So my end behavior. Are they going to be the same? No. For an odd, they're going to be different. So as x approaches negative infinity or infinity, whichever one you do first, right? So as on the left side, it's going to be heading up, right? Because it's a negative, right? So it'll be y approaches infinity. As x approaches infinity, y approaches negative infinity. Are we okay for the end behavior? Right? So up to the left, right, and down to the right. So that's what we're describing. Okay. Turning points. Turning points. Okay, for turning points, I want to know how many possible turning points there can be. So if you go, okay, I drew this, but it doesn't help me, so you can draw it a little bit fancier and do this. Do a little wiggle for yourself and go, okay. So how many turning points? I have to remember that it's an even number of turning points, right? So is this the even odd one? Yes. It has to be an even number of turning points. If I do an odd, it flips itself back around. So I know that the possible turning points is going to be how many? I have 5. So it'll always be 1 less, right? So it'll be 4. I can have 4 turning points. Can I have 3? No, because that turns it around. So 2 or 0. 4, 2, or 0. Good? Okay. Number of zeros. Okay. So the number of zeros. For the zeros, remember you can have up to the number, the degree that it is. Right? So when you're thinking about, okay, if I was going to put an axis through here, okay, that's how many I can go. 1, I can go 2, I can go as many as I want. So the number of zeros would be 5, 4, 3, 2, 1. Or 1, 2, 3, 4, 5, whichever. Okay, anything else? Oh, and sketch it. Okay, so let's draw two possible. So one of them I'll do 2 turning points, one of them I'll do 4 turning points. Or you can do 0 turning, that would be hard to do 0. I'm going to do 4 and 2. Okay, so let's do, I use these characters to draw 2 possible graphs. Okay, I'm going to do 2 possible graphs. It doesn't even say it has to be different number of turning points. I can do 2 turning points, but change the number of zeros. So as long as they're just not identical turning graphs. So if you're like, oh, you know what, I don't have to do that many. So let me graph this. Okay, right, so it doesn't say you have to change everything. You just show 2 possible. So I'm going to do 2 turning points just because it's easier, right? And then I'm going to have, I can do number of zeros. I can do, it starts at, okay, wait, sorry, look up for a second. The first thing I do with these guys here is that I go leading coefficients negative, and it's odd. So I know, and I do this in pencil, that it's doing this, right? So I know there's an arrow up here, quadrant 2 to quadrant, I do that. Right, so it's going from quadrant 2 to quadrant 4 because it's odd degree and it's negative, so sloping down. So I just put my 2 little arrows here just to kind of remind myself, go from quadrant 2 to quadrant 4. Right, and then I'm going to do 2 turning points. If I'm not making it do the maximum, don't make it more complicated. You can if you want. And I'm like, why not? I'm just going to do 2. And I just want 2 possible. So I'm going to go here, 1. I think I'll bounce on this and then head down. Okay. And if you want to change it up, I can do it again. I can go, I went right through it and then did this. 2 turning points. 1, 2, 1, 2, and it's odd. Right? And then go back and erase these arrows. Right? So those arrows are just to guide me. I like to know the quadrants. And it just says do 2 possible. It didn't say you had to do the maximum number of turning points. If it did, then you would turn like 2 more times. It didn't. I just said, okay, I'm going to do 2 turning points. That's pretty easy to draw. And I want to change it up, so I change the number of zeros. This one has 2. This one has 3. And that's good enough. Right? So don't overthink it. Like, if that's all the restriction is, then just draw possible. Okay. The next one, same thing. I always think in my head, leading coefficient, right? So I'm going to do here in the bubble. Just zoom out a little. Okay, so leading coefficient. So my leading coefficient is positive. So that's all I need, positive or negative. I don't actually need the number. Okay, and the degree is 4. So even. That's what I need. I need to know it's even, and I need to know it's positive. Right? So you go, oh, I only need that. If it's even and positive, in my brain, I think, okay, then that tells me it's like an even positive parabola, so it looks something like that. So then I know when I draw it, I know that the 2 arrows should be up in these 2 quadrants. Right? So it's going from 2 to 1. Okay, so I got that idea in my head. Now, let's answer the questions. So end behavior. End behavior as x approaches. Now this is the one where both of the end behaviors should be facing the same way. So you can save your time and go positive, negative. I know they're the same. Positive, negative. And it's going to be infinity, right? Both of them are facing the same way. Y approaches infinity, up. Okay. Okay, and the turning points. How many turning points can it have? It'll be 1 less. So again, think of this. It has 1 turning point, and it's a degree of 2. It's 1 less. Remember, it has to be odd number of turning points. So I'm going to go, if it's a degree of 4, it would have 3 or 1 turning point. Can't have none, because it won't be facing the right way. Okay, how about the zeros? For my zeros, how many zeros can that parabola have? None, right? It can be open up, down, it can be above or below, so it can have 0, 1, 2, 3, 4, all the way up to the 4. You can go 4, 3, 2, 1, 0, or I don't care. 0, 1, 2, 3, 4. okay, or 4, 3, 2, 1, same, and just a quick sketch. Right? And that summarizes a lot of what we just talked about, right? So that actually covers a bunch of the things we were talking about on the other page. So we're going to do, I'll just try, see, we could even do a turning point of 1, make it look like a parabola, right? So there's nothing wrong with that. You can do a 3 and a 1, just do 2 different ones. It just asks you to do 2 possible. So I could do 1 and say, okay, it's a turning point of 1, and it opens up. People go, but wait, that's not going from here to here. But it is, because this keeps going. You were like, but you have it from 2 to 2. It's not. This is supposed to keep going, so it will eventually get over here. They're like, wait, you didn't listen to your own rule. Does that make sense? You're like, but it will eventually get to the 2. So that means that they're both opening up, like that, up and up. And if you want, you can do something more fancy and go, okay, well, I'm going to do from here, 1, 2, 3, touch it once. Whoops, sorry, my hand hit that, like that. 1, 2, 3 turning points with 1 root, stuff like that. So they're just saying, give me 2 possible ones. Sometimes we'll be more specific and we'll say, can you draw me one with 3 turning points, with a upper bound, stuff like that, and 2 roots. So you got to make sure it hits twice, so they can be more specific, right? If I want to mark it kind of more concisely, because there's like so many possible, so I could say make sure that it has 2 roots, has whatever number turning points, etc. All right, good enough. We'll do the last one when we come back tomorrow. But there you go.